Okay, we're going to start with periodic functions. And then we're going to get to sine and cosine functions, so the sinusoidal functions. But first, what a periodic function is a function that has its pattern repeat itself in a given period, so in a given horizontal distance or domain. Okay, so if f of x is periodic with a period of x equal to 5, then f of 2 equals f of 7. Okay? So if the period is 5, then that means in every 5 horizontal units, okay, or every 5 units in the domain, the y value repeats itself. So if I go another 5 units, it's going to be the same as well. If I went back 5 units from 2, it would be the same, and so on. If I added 25 units to 2, so f of 27, that's also going to be the same y value. Okay? So every 5 units, the y value repeats itself. So here is an example of what a periodic function might look like. Okay? And you can see that the period of this is 5, and at 2 units in, f of 2 is 3. If I went to f of 7, it should also be 3. f of 12, it should also be 3. Okay, so that's a rough sketch of one example of a periodic function. Here's another example of a periodic function. And again, f of 2 here equals 4, f of 7 equals 4, f of 12 equals 4. So if the pattern repeats itself in a given number of units, then it's called periodic. Okay? So here is some more information. Okay? So the period is the length of one cycle. Okay? That's what we call the period. The amplitude, well, this is maybe a little bit different than what you might think. You might think that the amplitude is the vertical height of the whole thing. Well, it's close. It's half of the vertical height. Okay? And I think where they get that from is maybe from like waves in an ocean or something like that. So if you look at a lake, and you look at the waves and they go up and down and up and down and up and down, they're periodic. Now if the lake was calm, it would look like this. Okay? So above sea level, the waves are only going that much. They're not going the full height of the whole wave, they're just going that much up and that much down. So the amplitude is half of the wave height. Okay? So the maximum minus the minimum divided by 2. So that's the amplitude. Okay, in example 1, up here, the amplitude is going to be the max, which is 3, minus the minimum, which is 0. So 3 minus 0 is 0. And then divide that by 2. So the amplitude of this wave is 1.5. The second wave, well, it's going to be the max, which is 4, minus the minimum, which is negative 2. So 4 minus negative 2 is going to be 6. 6 divided by 2 is 3. So the amplitude of this wave is half its height. So from negative 2 to 4 is 6. So half of that is 3. Okay? And then we have the equation of the axis. Okay? So the equation of the axis is the horizontal line that cuts the function in half. Okay? A little different from the amplitude. This goes a line that goes through the middle. So instead of subtracting here, we add. So if we want to find the middle of two numbers, we just find the average. We add the two numbers and divide by 2. So the max plus the minimum divided by 2, and then it's y equals that. So y equals 1.5 for the first one, which makes sense. 1.5 goes through the middle. But in the second one, the amplitude is 3. But a line through y equals 3 would not cut that in half. The line has to go through 1. So y equals 1 is the line that cuts the second example in half. Okay, and that's some information about periodic functions. Now, the periodic functions that we're going to deal with the most are trig functions. So I'll show you a quick picture here of a sine graph. So this is a sine graph. So sine of 0 is 0. Sine of 90 degrees is 1. Sine of 180 degrees is 0. Sine of 270 degrees, negative 1. And sine of 360 is 0. And then if you rotate again, go on to 720 degrees, you would see that pattern repeat itself. If you went backwards, you'd see that pattern repeat itself. Now you're probably wondering where I get this circle here from. Well, this is called the unit circle. Okay, so its radius is 1. And how we get this sine graph, I worked from the special triangles. So I draw an angle of 30 degrees in here, 45 degrees, and 60 degrees. And then I go around and do multiples of those, 120, 135, 150. This would be 180, okay? And 210, 225, 240, 270, 300, 315, 330, and then back to 360. And if you look at the sine of an angle, sine equals y over r when you're using the Cartesian definition of it. If you're using a circle that's called a unit circle, the radius is 1. So with a radius of 1, r just equals 1. So this makes it convenient for trying to make this graph. So sine of theta equals y over 1, which is just y. So if I look at any point at the end of these terminal arms here, the sine of the angle is just the y-coordinate of that, or just the height above the x-axis. So using this special triangle with the 30, 60, 90, this height would be 1/2 if the radius was 1. Okay? So I'd go sine of 30 equals 1/2. I go across to 30 degrees. There's a half. Sine of 45, well, that's 1 over root 2, which is about 0.707. So that, I go across to 45 here. That's where I put that point. Sine of 60 is root 3 over 2. Go across 3 over 2. I hit 60 degrees in the graph. And there is root 3 over 2. Then sine of 90, well, the y-coordinate there is 1. So I go across, and that's 1. And that's the highest it goes, because afterwards it goes back down. The y-coordinates go down. And the way I measure these out, well, you measure out 360 degrees. Then with your ruler, cut that in half. You got 180. With your ruler, cut that in half. You got 90. Cut that in half. You got 45. And that you can mark out across there. Now, my 45 degrees, each one is 2 centimeters. So then to get 30 and 60, you got to make sure you don't go right in the middle of 45 and 0, because 30 is not the middle of 45 and 0. So 30 is 2/3 of it. So if that's 2 centimeters, 30 degrees is about 1.33 centimeters. So you're going to mark that in there. About 7 millimeters back, 7 millimeters forward would give you these two. Okay. Now, as you go across here to 120 degrees, sine of 120, well, the height there is the same as sine of 60, which is root 3 over 2. So I can go right across here to 120 and mark that point. Same with all these down here. Down here, the sines are going to be negative because the y values are negative, and you map those across, and you end up with this nice sine curve. You do the same thing, you can get the cosine curve. And for the cosine curve, what I would do is, I'm just going to do this roughly. Okay. Make a circle here. All right. And I would make this the x-axis, so this is 0 degrees, because cos of theta equals x over r, which equals x over 1, which equals x. So if I want to map this right across to this graph here, so there's 360, 180, 90, 45, and so on, 135. If I want to map this right across, there's 0, there's 90, x is this axis, y is this axis over here, and so cos of 0, well, cos is x, is 1. Cos of 0 is 1. Cos of 45, say, is 1 over root 2. So I go over and plot that point there. Cos of 90 is 0. And then I'd go down here. Cos of 135 would be here, and then cos of 180 would be there. Okay, and you get this curve that goes like that. And then if you keep going around, it ends up going back up like that. So there would be the cosine function coming through there at 270. Looks like the sine function just shifted back. Okay, so if I continued back this pattern here, I'll go back here at negative 90. Okay, so it's just really a translation of the sine function. So there's the cosine function. There's a sine function. And these are periodic functions because if you continued on every 360 degrees, you would get the same pattern repeating itself. Okay, so that's it for an introduction to periodic functions. Next video we're going to do transformations of the sinusoidal functions.